Hey everyone, we're going to construct a Cayley table for set G, which has elements 1, 3, 7, and 9 under the binary operation multiplication, modulo 10. And we're going to answer all these questions and we'll get started. So basically we want it under multiplication modulo 10. So just write your elements on the horizontal and on the vertical, first column and first row, and then multiply. So 1 times 1 is 1, 3, 7, 9. This one's going to be easy. Do it again with 1, so it's 3, 7, 9. All right, now after that, you go 3 times 3 is 9, so that's just 9. 3 times 7 is 21. Under modulo 10, divide that by 10, and you'll have a remainder of 1. And 3 times 9 is 27. Divide that by 10, and you'll have a remainder of 7. 7 times 3, we've already done that one. We got 1. 7 times 7 is 49. Divide that by 10, you have a remainder of 9. And 7 times 9 is 63. Divide that by 10, and your remainder will be 3. 9 times 3 is 27. Divide by 10, your remainder is 7. And then we already knew that's 3. And 81 divided by 10 will give you a remainder of 1. So there's your Cayley table. We have to show that it represents the group. It represents a group because all our numbers in here are in this set. So that means our table is closed. Okay. Secondly, we have an identity element of 1. Three, the 1 appears once in every row and once in every column. So that's how you tell for this. So once in every row, once in every column. So that means we have an inverse for each element. Namely, if you look at, let's say this one, 7 and 3 are inverses here. And then 9s are also inverses. All right, so for multiplication is associative. You have to prove that. You don't have to really prove it. You can just say multiplication is associative. So is addition. So you don't always have to keep proving that. All right. Explain how the table indicates that the group is abelian, a commutative. So what you do is you look at this main diagonal here. Let's see. Here's your main diagonal. And looking at that, you look on either side of it, and you see it's symmetric. You can even look there. So along the main diagonal, we get the same number. And you can even further it out. So we get 7 here, and then 9, and then we go back to 9. So if it's along the main diagonal, if it's symmetric, then it means we have symmetry about the leading diagonal. So you would write that down. Symmetry about the leading diagonal. All right, now let's go further. All right, use Grangers Theorem to explain why we cannot have a subgroup of order 3. So basically what Grangers Theorem says is if we have, our group has G star 10 has order 4. That's the number of elements. That means that the subgroups cannot have an order that's not a multiple of 4. So multiple of 4 is 1, 2, and 4. So 3 is not a multiple of 4. Therefore, the subgroup cannot have order 4. So let's write down the subgroups. So writing down the subgroup, you have your identity, and you want your proper subgroups. Now, proper means that, let's call H the subgroup, has to be properly a subgroup. This is not a proper subgroup. So we only have to get the smaller groups, basically. So we have our identity. That's a subgroup. And then let's look and see if we can do any others. Another one we have is 9. So 1, 9. So that gives you smaller subgroups. And I couldn't find any others, so those are 2 main subgroups. Now, we have to show that it's cyclic and state all the generators. So basically, the order of the subgroups has to equal the orders of the groups. So let's look at the each element. So the order of element 3. Let's look at that. So that means you do 3 to the first, since we have 4, 3 squared, 3 cubed, and 3 to the fourth. Now, when you write those out, you're going to get 1, 9, 3 cubed is 27, and, this equals 3, sorry. And divide that by 10, your remainder will be 7. And 81 divided by 10 is 80. Your remainder is 1. So order of element 3 is 4. So this order is 4. And it matches the order of the group. So hence it's cyclic. Another generator, and you always want to look at the inverse. So the inverse of 3 is 1. So let's look at that. 7. So since we already have this one, let's do 7. This one's harder without a calculator. This is 7. 49 divided by 10 leaves you 9 as the remainder. And then 7 cubed is just going to be 7 to the first times 7 squared. So 7 and 9, that's like 7, 9, gives you 3. So I just looked at 7, 9, gave me 3. And 7 to the fourth is just going to be 9 star 9. That's just 2 of those. So that's going to give you 1. So both 7 and 3 are generators of the group. And then finally it says solve x star 3 star x equals 7. So just looking at the group, I'm going to write this as x star 3 equals 7. So I need this has to star 3 is 7. So I look at 3, go down to 7, or you can do it this way. Look at 3 and go to 7 and you get 9. So this has to be 9 here. So now we need 2 x's that gives us a 9. That the numbers are the same. So what 2 numbers both give you 9s, and that's 7. So 7 star 7 gives you 9, and 9 star 3 gives you back to 7. So that means my x's has to equal 7. And that's it. Thank you. Have a nice day. Bye-bye.